Hello students, in our last video I showed you how to do partial fraction using MATLAB. Today we are continuing with part 2 where I will guide you through two more examples. But this time we are not stopping at just understanding partial fractions. We are also going to figure out how to get the inverse Laplace transform from this partial fraction. Let's get started. So here you can see this is the example number 3. So obtain the inverse Laplace transform of the following function, that is fs. So we use MATLAB to find the partial fraction expansion of fs. So first step, we use this function to convert into the partial fraction, then we use the inverse Laplace transform to find the t domain. Okay. So here you can see this is the MATLAB code. So you already know, just you have to write the numerator coefficient, denominator coefficient, then you have to write the residue. Then so here you can get the partial fraction. Then you have to use the inverse Laplace formula. Just remember this command. So SYMS. So just define the variable, that is the s, then you have to write the function, then just use the command I Laplace and f, then you can easily get the inverse Laplace transform of the fs. Okay, so without doing partial fraction you can directly get the Laplace transform inverse Laplace transform by using the I Laplace, but here initially we are doing partial fraction, then we convert it to the inverse Laplace. Okay, so just I am going to the MATLAB. So I am writing the coefficient of the numerator. So it will be num equal to 1, 8, 23, 35, 28 and 3. Next I am writing the denominator coefficient, that is 1, 6, 8 and 0. Now I am using the command, that is the RPK. R is the residue, P is the pole and K is the direct term, equal to RESIDU residue, and write the num comma day. Okay, so just run this program. So here you can see the value of the R, P and K. So the equation will be the 3.35375 divided by s plus 4 plus 0.250 divided by s plus 2 plus 0.375, this is the 0. So 0.375 divided by s plus, this is the direct term, so it will be the a square plus 2s plus 3. Now we use inverse Laplace command to get the t domain or inverse Laplace. Okay, so just remember the command. So just we have to define the variable, that is the s. So SYMS s, then you have to write the function, that is the f equal to 0.375 divided by s plus 4 plus 0.25 divided by s plus 2 bracket close plus 0.375 divided by s plus s square plus 2s means 2 star s plus 3. Then just write the command, that is the inverse Laplace, I Laplace of function f. Okay, so run this program. Okay, so here you get the result. So that is the e to the power minus 2t by 4 plus 3 by 8 e to the power minus 40 plus 3 del t plus 2 d2 del t by dt plus, sorry, it will be the 2 d by dt into del t plus direct 2t means d2 by dt2 into del t plus 3 by 8. Okay, so here you can see. So here we got this function 0.375 divided by s plus 4, 0.25 divided by s plus 2 and plus a square plus 2s plus 3. This is the direct term. So after taking the Laplace, so it will be the d2 by dt2 del t. So here you can see this one, and 2 d by dt del t, this one, and 3 del t, this one, and plus 0.375 e to the power minus 40 means 3 by 8. Okay, so now going to the second example. So here you can see this is the second example, that is 2 by s cube into s square plus 2s plus 10. So I am directly going to the MATLAB. So here you have to write the numerator portion. So I am clearing. So just write the numerator. So here numerator is only 2, only the constant term is there, and coming to the den, that is the denominator. So write the coefficients, that's are 1, 2, 10 and 0, 0, 0. Then you have to write the common, that is the r, pk and residue number and den. So here you can, so just omit this command. Okay, so here are the output. So here you can see r values is that 0.0060 minus this I, this is the plus, and total the 5 roots are there, and this is the p values. So here you can see total 5 poles are there, and k constant term is the 0. So here we got the result. So here you can see, just we take one more step, just we multiply this complex number, we get this number, that f is equal to 0.012 s plus 1 plus 0.0522 divided by s plus 1 whole square plus 3, then minus 0.012 divided by s plus minus 0.04 s square plus 0.2 by s square. Now I have to write these functions in the MATLAB. So just define the variable, that is the s. Okay, then write the function, that is the, so you have to write the functions, that is 0.012 multiplied with s plus 1, okay, plus 0.0522, so I am closing this bracket, divided by s plus 1 whole square plus 9, s plus 1 whole square plus 9. I am also taking one more bracket. Okay, so this is the numerator, and now I am closing overall. So this is the first portion of the partial fraction. Then second one is the minus 0.012 divided by s, okay, minus 0.04 by a square. So and third portion is the 0.2 divided by s cube. Okay, so then just write this I Laplace of function s f, and we will get the inverse Laplace. So here you can see t square divided by 10 minus t by 25 plus 3 e to the power minus t cos 3t plus 29 sin 3t divided by 20 by 250 minus 3 by 250. So this is the output. So here the inverse Laplace transform of the fs is given here. So without partial fraction you can directly write these functions, that is x is equal to 2 by s cube into s square plus 2s plus 10, then you can directly get the inverse Laplace transform. But it is the partial fraction, that's why I just convert this into the partial fraction, then I directly convert to the inverse Laplace. Thank you.